Hi, welcome to the first in our video series to talk about LearningCurve, or I should say to learn about LearningCurve. You can see the agenda here. I think we've got, we're covering a little bit of theory, what LearningCurve is. We have probably 3 different example problems throughout. So let's go ahead and get started. Additionally, you've had an article that you've read that you'll have a quiz on in class as well to help supplement the material of what the learning curve is. Okay, so let's go ahead and get started with the learning curve phenomenon here. So you know from reading the article, if you have read it already before looking at this video, that the learning curve phenomenon says that for every unit that is produced, the time to produce it gets shorter. And the learning curve is the equation, is how fast the learning curve, how fast the learning takes place. So it's an important topic in time study, and maybe I'll save that for a discussion in class, but why do you think it's an important topic in time study? Think about back early in the quarters when we set the standard time. Where in the learning curve would you want to set the standard time? So maybe just think about that as we talk through that. And let's see, I kind of talked about these things already. And so the steeper the learning curve, the faster the worker is learning. And the less steep, and so 60% curve is actually is a very steep curve, you know, very relative to a 90% curve. So 60% learning curve says that we're learning 40% more, or reducing our time 40% more for every unit that we produce. A 90% learning curve says that we are learning enough to reduce the time by 10% for every unit that we reduce. And that 10%, it's the 10%, talking about the 90% learning curve, is a 10% throughout the whole thing. So as the time per unit drops, the amount of, I don't know if I want to say value, but the amount of time that 10% means or quantifies is less and less, is what this last bullet is saying. So the further down in the learning curve, we still get benefit from the learning, but the benefit is less and less. Like instead of a minute reduction per unit, it's now, 5-second reduction per unit, something like that. So based on what you read in the article and what we just talked about right now, come to class and we'll talk about these 3 questions here. Does the learning curve continue infinitely? So does it go, if we start out at a minute for the first unit we make, can we get down to 0 or even to 5 seconds for a unit to be made? So does it continue infinitely? And why is the learning curve important in time study? So it's kind of, I talked a little bit about it here. I think the article covers a little bit, and you'll hear some more as we go through the videos here for you to bring to class with that. And would you prefer a 90% learning curve or 60% learning curve, and why? So I would like you to pause the video right now, or at the end of this video, have the slide printed out or something with these questions and write down some notes, some ideas about that. And you can add to it as you go through the videos, and we'll talk about them in class. Okay, so that's the learning curve phenomenon, is that the time to produce a unit decreases with the more units that you make. So next is, why does a learning curve occur? What makes the time reduce? And we're going to talk about it in terms of 2 paths: the contributions of the worker, which you see here on this slide, and I think our next slide is contributions of the organization. So the contributions of the worker, anything, I would assume practically anything you've done, that the first time you do it takes longer than the second. That's why as you're going through college here, every course is new, right? So it's not easy. It takes longer to do the homework. It takes longer to understand because it's the first time you're becoming familiar with the task. But if you, let's hope you don't have to, but if you retake a class, it's easier. Or think about for me, in reality, I knew the material coming into the class, but every time I teach it, it gets easier for me to teach in a shorter amount of time, or a better way of understanding. At least I think so. You can let me know that at the end of the quarter or not. And then as you get the hang of doing something, I say as the worker, makes fewer mistakes. So you don't have to go back and rework, takes less time. You become efficient in how you lay things out. Think about our flashlight assembly back at the beginning of the quarter, and hopefully you've saved those times because you'll be able to calculate the learning curve of the flashlight assembly. And I'm willing to bet that most, if not all of you, saw a reduction in time from the first flashlight you assembled to the 10th flashlight you assembled, because you set up the workstation better, you got used to the size and the shape of the parts and putting them together. So developed that rhythm and became more efficient. And that kind of relates to the second bullet here. And then fewer delays that interrupt the operation as you're going along. Just as a worker, you try to be more efficient as you go through. So something to think about is, does this have any application to your project? Can you think of how a worker, do you have a lot of new workers, and what is the learning curve for that? And we'll talk later, you're going to have a lab about learning curve too, how you can calculate the learning curve from the data that you have, and we can use a direct time study from the flashlight assembly if you don't have anything from your class. Or is the learning curve just not relevant at all to your project, to a particular worker or not, and why would that be the case? So be thinking about that and be able to answer that question as well. So those are the contributions of the worker. And so do you think if you have only the contributions of a worker, let's just say flashlight assembly, could you get it down to 0? Probably not, right? Because you have to do, there's some work content that has to be done. So maybe there's an optimal type thing, but probably not, right? And we'll talk about my doomsday attitude a little bit later in the videos. But now let's talk about contributions of the larger organization. So these are things that would require money, that would require time, that probably go across, impact more than just the worker's workspace, tooling, things that they have control over. So on the prior slide, those are all things that the individual worker has control over. Now here's some things that the larger organization can do that would make the time reduce from unit to unit. So what we're learning about in class this quarter is the methods improvement by the industrial engineering analyst or department, right? Maybe a reset up, maybe a better materials. I don't know if that's on the list later or not, something like that, but a better improvement, a better workflow, better steps. And you learn that by using, by observation and your operations flow process chart, that kind of thing. Fine-tuning of machinery and tooling and special tooling. So maybe that means that we have something in place that helps us align the parts better and quicker. Think about the flashlight assembly with the little flange. If we had something to align that more quickly for us, then that would probably shave a little bit of time off, something like that. Technological improvements. If we go from manual to machine, or from manual to semi-automated, something like that. Product design improvements. I think we might have talked about with the flashlight assembly if we have it snap-on instead of screw-on, and so that's a product design that we would go back that would take some time off, and then the learning curve probably would be shorter for that as well. Better materials so that it takes less time to put things together. Better scheduling, logistics support, so material and people are there and that sort of thing. Motivation of the workers. So maybe there's a company in Grover Beach called Volet, and they make clothes for bicyclists, and they pay piece part rate, meaning that if a sewer sews 10 shorts in a day, they get X number, they get paid by how many pieces they sew. So if they sew more, they get more money. So maybe that would be considered a little bonus, or a bonus if you go over a particular standard that is set or expectation, something like that. Motivating the workers to go faster. Doesn't always have to be financial. Maybe it's to go work on some other project or to move to a different job, something like that. But those are the contributions of why the time to make a particular item might decrease that are a result of the larger organization. And notice all of these are out of the direct control of the worker because it requires some additional resource, some additional money, working across departments to make these kinds of things happen. And so I want you to think about in regards to your project, do you have any of these applications that the larger organization could do to improve the time it takes to make a particular item, whatever your item is? And maybe that means early on in the learning curve, or maybe that means once it's asymptoted out, and you should understand what that means from the article, and you'll see what that means later on as well. Okay, so we've talked about contributions of the worker and contributions of the larger organization. And I'll close out this video with just a slide that tells you what typical learning rates are from different industry. It says LR, but really that's learning curve, and the distinction will be important when we talk later in the other videos and working out some of the problems, but this is a learning curve. So you can see based on the type of work and industry what the learning curves typically are. And so another thing might be to think about is your project in any one of these industries or one of these types of work, and if you collect data, is your learning curve the same? Or if you have someone that's been there for a while, you should be able to time them or time their workflow, and what would you expect the learning curve to be if it's a worker that has been doing it for a while, already has the pace down? You expect it to be pretty darn high, right? And so you could test that hypothesis by collecting the data and calculating the learning curve from that data. So even if you don't have new workers in your project to do what you would think a typical learning curve analysis, you can test the hypothesis on an experienced worker, and again, you would expect a very high learning curve, like 100%, right, or 98 or 99. And we'll talk about the interruptions, why it might not be 100 in the next video. So that is the introduction to learning curve, and we'll move on from there. Thank you.